I've been working on the Python to Desynced cross-compiler, and I want to show you how to use its latest incarnation. First, I'll give a quick tour of the system, and then I'll develop a simple deconstructor behavior to test it out. The biggest change is that it now runs in the browser. Just click the link below, and wait for it to finish initializing, and you're good to go. For the coding example, I'm going to recreate the disassembler/deconstructor bot from a previous video. You may remember this as the bot that looks for and recycles units that are signaling the down arrow of deconstruction. Let's take a look at it in action, clearing out some things that are no longer necessary. So right here, I have some buildings that I no longer need, and so I'm going to select them. I'm going to set their signal to the down arrow. And my deconstructor bot, as soon as I turn it on, will look for it, find it, and begin disassembling them. Having seen it in action, let's reproduce it in Python. I'm going to start by just producing a quick function header, and take some notes on what I'm trying to do. So the first thing I'm going to do is find the signal, and I'm going to look for the down arrow. Once I find that, I'm going to deconstruct. And then this is an important step. I'm going to wait for deconstruction to finish. With the outline finished, let's start on finding the signal. I'm going to start by creating a blank variable named target. The underbar in this context means null, zero, blank, void, whatever you'll have for it. And then I'm going to loop over a set of potential matches in the LoopSignalMatch. And you can see the autocomplete tells me that there's a deprecated loop signal, and what I'm looking for is LoopSignalMatch. And specifically, I'm looking for the down arrow. I don't know the constant for the down arrow off the top of my head, so I just type in down. Autocomplete suggests arrow down, and I select that. Now I'm going to say my target is going to be updated with SelectNearest between the target and the potential. And this should be a pretty standard loop that finds the nearest signal source that matches the V arrow down. Let's take a look at what that looks like in Desynced. To do so, I'm just going to hit compile, and that produces this green hash code, which is the compiled output. And I can copy that either by clicking copy here, or by double clicking and copy pasting with Control-C, Control-V. With that copied, let's get it into Desynced. I'm going to take my deconstructor, which is a dashbot with a deconstructor and a behavior controller. I'm going to open the behavior controller, go to library, and then go to the bottom of a folder and click load. This is going to load from the clipboard. And looking through this, I see that I have the variable a being assigned to a blank value, which corresponds to target equals underbar. And then I'm doing a loop signal match over the down arrow, putting the entity that's creating that signal into variable b, and then I'm going to update variable a with the nearest of those two. So far, so good. So it looks like the code is doing what we've asked it to, but we have no way of knowing because I cleverly forgot to provide a way to debug it. Let's do that now by changing the local variables into parameters. We do that by putting them in the function definition. So by saying target and potential up here, that's going to take these variables and turn them into parameters P1 and P2. And when I copy and compile that in, let's take a look at what it looks like. The updated code is exactly the same as it was before, but now instead of using A and B, it's using P1 and P2 and has labeled them. By making them parameters, we're able to see them from the global screen in this view here. So if I hit play, we'll see that it's identified that this building has the down arrow, which asks for deconstruction, and it's correctly identifying it, but we don't have any code to act on it yet. To do the deconstruction, let's do SetToComponent. We're going to set our target, and we need to tell it which component, which is the deconstructor. So again, I'm going to rely on autocomplete and find the C deconstructor. Copied in, let's take a look at the code in action. So I have a target here, and I'm going to go ahead and start. And you'll notice that we have the same bug that we noticed in our last video, which is that this loop executes so quickly that it starts deconstructing this building before it's finished deconstructing itself. Let's fix that with a busy loop. To create our busy loop, we're going to do a while match. And we're going to check that our target is still a building. Since we don't have anything to do while we're waiting, we could do a wait, but I'm just going to put a pass here. The while loop has been successfully translated here. Now let's take a look at the behavior in action. So I'm going to start the behavior, and I'm going to take all of these specially constructed buildings for the purpose and ask them all to be destroyed at the same time. If we've done this correctly, we should see it identify them, deconstruct, and wait for the full deconstruction each time. Looks good. I hope you find this helpful, or at least interesting. I've personally found that it's a little slower for making very simple behaviors, but it does show its worth with anything complicated, especially complicated loops, or really anything that gets edited frequently. Let me know if you find it useful, or what features you would need in order for it to be useful to you. If you're interested in contributing, please feel free to reach out, or just start making pull requests to the GitHub. I'd be really appreciative of any input from front-end folk. I haven't done anything web dev since the Blink tag and MySpace. And also, 3 of the programming languages used in this project were new to me. That is to say, there is plenty of room for improvement. Thanks!